All right, we are going to continue in in Unit 6 with Lesson 6.2. And this is kind of a weird lesson, I think, because there are so many little things that kind of come together. So we are going to cover a lot of different things, but also a lot of it requires previous knowledge. So hopefully it won't be too overwhelming, but we're going to look at it together. So first of all, write the expression x plus 1, and x plus 2 as a polynomial in standard form. So we've been given these, later we'll talk about them being linear factors. And what we need to do is basically FOIL and then kind of FOIL again, so that we're making one big long polynomial equation instead of three separate polynomials. So it does not matter which two you start with, if you FOIL like the first two, or if you FOIL the second two, or the first and the third. I'm just going to put the first two together since they're right there. And so we know that FOIL says do the firsts, which would give us x squared, the outers, which would give us plus x, the inners, and then x, and then the last term, so plus 1. And if I rewrite that, I'm going to get x squared plus 2x plus 1. And then we've got x plus 2. And then next, I need to distribute this again. It's technically not FOIL because this one is a trinomial instead of a binomial. But we're going to distribute that x squared to everything and get x to the third plus 2x squared. And then I'll distribute the 2x to everything. And I get plus 2x squared plus 4x, and finally distribute the 1 to everything, and we get plus x plus 2. And our final step would be to combine our like terms and make sure that it's in standard form. What does standard form mean again? It means that that there's no like terms, and it also means that our exponents are in descending order. So when I look at my like terms, I've got those, I've got the x's. X to the third did not have another one with it, so just x to the third. This would give me 4x squared. 4x plus x would give me 5x, and then plus 2. And then I've got 3, 2, 1, 0, so I'm good. This is standard form of the polynomial. All right, so now we're going to go the other way, and we're going to factor something where our x was not squared. But what's the first thing we always look for when we're factoring? GCF. GCF, and in this case, what is my GCF for this polynomial? What can I divide all of these numbers by, or all of these terms by? I can divide all of them by 3x. And so what's going to happen is I'm going to bring that 3x down, and it's going to go in front of my parentheses. And when I take out a 3x, I'm left with 2x squared minus 5x minus 12. And I can double check now. I don't have any like terms. This one doesn't have an x. 5 is not divisible by 2, so that is factored with the GCF. But we can break it down further. This is using what we did last unit. And we're going to multiply that 2 by the 12. And we get x squared minus 5x minus 24. Oops. And so then I've got x minus 8 and x plus 3. But because I multiplied by 2 to begin with, I have to now divide by 2. And that 2 comes in front. And a really good way to check your work is to look at your starting degree of the polynomial, and it was a 3. So that means that there should be 3 x's in my final answer. I've got 1, 2, and 3 x's. So that means that I did something right. That's a quick, easy way to check without actually multiplying everything back out. You could FOIL this and multiply it back out and see if you get the original problem, but that's an easy way to check for silly little mistakes. All right, so some key terms that we do need to know are relative maximum and relative minimum. And these are just the highest or the greatest value of a graph or the lowest or least value of a graph. So you can see this graph technically would keep going forever and ever in either direction. So there's not one maximum or one minimum, because this graph right here is going to keep going further and further. And so it's never going to reach the lowest point. So we call it relative, because when we zoom in and we look at this big picture, we're saying, well, if you exclude the fact that it extends to negative infinity over here, this right here would be my relative minimum. And if you exclude the fact that this would continue on and on forever and ever, this would be my maximum. And we actually looked at minimums and maximums in the last unit, but we didn't call them that necessarily. When we were graphing parabolas, what was our minimum or maximum better known as? It was better known as the vertex of the parabola. So we looked at problems like this, where this was just the minimum because the graph never gets lower than this point, or the maximum because it never gets higher than that point. So now we're looking at relative maximums and minimums, and I'm going to show you how to do that on your calculator. So find the zeros of y equals this, then find the relative minimum and maximum. Zeros is just another word for finding the point where the graph crosses the x-axis. So a zero is where the graph crosses the x-axis. If we were talking about solving it, that would actually be the solution then as well. So we are going to take, just like we did with when we solved by factoring, these are already factored for us. We're going to take each factor and set it equal to 0. And so here I'm going to add 7 to both sides, and I get x equals 7, x equals -1, and x equals -3. So if I were to graph this, I know that I would have a point here at -3, at -1, and then all the way over here at 7. That's kind of what my graph would start to take shape as. But we are not going to do relative minimum and maximum by hand. We're going to use our calculator. All right, so I have my handy dandy calculator out, and I'm going to go to this y equals button. So second, y equals, and then I'm going to type in my function. I do not have to change it to standard form. I can leave it in factored form, and that's what's like pretty exciting to me, is I'm going to do x, -7. Okay. X minus 7, x plus 1, and x plus 3. Enter. And there it gives me my equation. And now I'm going to do second graph. And there it is. Oh my gosh, I can already see my relative maximum right here, because you see the graph comes up like this and then changes direction. So that's my maximum. My minimum is somewhere down here. I saw it come down like this and then come back up, but we'll talk about how to get that in a second. So I am now going to find the value of the maximum right there. To find the maximum, I'm going to use this F5 button for math, and I want maximum. It's right there. So we talked about this in the last unit, but you need to find, you need to kind of define your boundaries. So I'm going to move there's my cursor. So I need it to be somewhere to the left, because I want to kind of say, find the maximum value between this point, and this would be a good spot, and this point. And it's just going to tell me that my maximum is this. -2.055 is the x value, and the y coordinate is 9.027. Aren't you glad I did not make us do that by hand? All right, -2.0, I'll call it 2.06, and then 9.03. And then we still need to find the minimum. And so some people like to change the window so that they can see what the minimum is, but you really don't need to. So I'm going to just start off by finding, hitting F5 minimum, and I need to be somewhere to the left, so I would say that this is a good point, or left of the minimum, and it's somewhere down here, so that's a good spot. And then I need to go somewhere to the right, and I'm just going to move my cursor till it shows up again. Oh, there it was. I saw it for a second. All right. And it's going to tell me that my minimum is at 4.06, negative 105.03. So when I go back to this, I can write my minimum and maximum. My minimum, well, my relative minimum was positive 4.06, negative 105.03, and my relative maximum was negative 2.06 and 9.03. So our graph ended up looking like this. That's a really, really, really rough sketch, but that's what was happening. And so we found this point up here, the maximum, the relative maximum, and we found this point down here, the relative minimum. All right. Now we're going to go the opposite way. We already know what our polynomial is, or in the last one we were told what the polynomial is, but we're now going to write the polynomial. So for this one, what we're going to do is we're going to think about if we solved it, we would get x equals negative 4, x equals negative 2, and x equals 1. So kind of what we're doing is working backwards from this point up to here. Okay, so I've got my x equals values. Oops, there we go. There we go. All right, and so what I'm going to do is say I need to get the 4 to the other side so that it equals 0. So I would add 4 to both sides and I would get x plus 4. Here I would add 2 and I'd get x plus 2. And here I would subtract 1, so I would get x minus 1 because I'm trying to make them equal to 0. But then when I put them all together, I would get y equals x plus 4, x plus 2, and x minus 1. So really you can think of it as you're writing each one in a parenthesis with x and then the opposite sign. So this one was a negative, it became positive. So with that in mind, try this one, see what you get. All right, so you might have written something that looks like this. That 0 maybe threw you off a little bit. Another way that you could write this is to actually, it doesn't matter what order we write these in. If you don't want to write minus 0, you could just move that x to the front as like a GCF kind of looking thing. And you could write something like this. But if you wrote something that was like the first one, if you put x minus 0 or x plus 0, there's nothing wrong with that. But then these do say to put them in standard form. So I wanted to look at how to put them in factored form, but now standard form is where we're doing the multiplication back out. So I'm going to do FOIL, and I'm going to get x squared plus 2x plus 4x plus 8, x minus 1. This will give me x squared plus 6x plus 8, and then x minus 1. When I multiply that back out, I'd get x to the third minus x squared plus 6x squared minus 6x plus 8x and then minus 8. And then combining those like terms would give me x to the third plus 5x squared plus 2x and minus 8. And this would be my final answer in standard form. So try putting this one in standard form and see what you get. All right, I wanted to show you two different ways to do this. Some people may have decided to distribute that x first, and so that's what this is, where you're distributing the x to everything. Some people may have decided to do FOIL first, but what you can see is that it's the same number of steps, and we should end up with the same solution. So which method did you use, and which one do you think looks a little bit easier for you to use? All right, be on the lookout. There's going to be a second video talking about one topic separately, and but for what we've covered here, Let me know if you have any questions.